I will start out by first talking a little bit about visual observing. I just quickly threw this together as I saw as a bit of something that we hadn't really touched upon today to make it clear for everybody. So what can you actually see in the night sky from the city? Now, we've talked a lot about the types of objects that are in the sky. We've talked about how different telescopes are better suited for different objects because of their size or how dim they are, but we haven't really tied it back to what do you do if you live in the city. So I have 3 slides here that sort of break up the types of objects and the type of telescope that they're best suited to observe. Starting with a small, inexpensive refractor or binoculars. So these are large angular size objects in the sky. So we already talked about M31, the Andromeda Galaxy, which is quite close to us in relative terms. And it's quite bright and large. So you need something with a wide field of view to see it. Similarly with some of these other objects like the upper middle images of the North American Nebula, it's actually quite large in the sky, much larger than M31 is, along with some other emission nebula like M42, the open cluster, the Pleiades, M45. It's a fairly large object to see all in one field of view that you need something like a small refractor or a binocular. And then, of course, the moon and the sun, because they're so bright, you can easily observe them with any type of a device. A small refractor, big refractor, doesn't matter. Now, to observe from the city where there is a lot of light pollution, you're really only going to be able to observe the objects that I've circled in red. So objects that are much brighter than some of the other ones. So the North American Nebula is quite dim, and because it's primarily emission from hydrogen, its wavelength is way down in the red end of the spectrum, and at night with your eyes you can't actually see that. So you will not see the North American Nebula from the city. The other objects though, like M42, it's very bright nebula, you can emission nebula, you can see it. M31, the galaxy, it's quite bright, you can see that. And the Pleiades open cluster, you can see it easily. Well, if you have a medium-sized refractor, so you know the 4-inch range, 3 to 4-inch range, then that opens you up to objects that are a bit smaller in physical size or angular size in the sky. So globular clusters, so the example here in the middle upper image is a good example. The Trifid Nebula we saw some pictures of, and planets become a target that you can observe now that you have a bit more magnification using a larger refractor. Galaxies are also a possible target, but they need to be brighter and fairly large in angular size. So M51 is a good example. M101 is larger, but it's a bit dimmer. M33, those are all galaxies because they are closer to us. They are brighter in the sky and they're larger in size. So they are potential targets for a refractor. And of course, the moon and the sun, easily you can observe with a larger refractor. Now, from the city, realistically, you're only going to be able to observe globulars, planets, the sun, and the moon with a large refractor. These smaller nebulae and galaxies, unfortunately, from the city, the light pollution impedes your view too much. You could use a light pollution filter on the nebula, and you might be able to see it, but the observing of it is not going to be very pleasing. And galaxies, visually, there's no filter that you can use to get rid of the light pollution, unfortunately. With a camera, yes. With a naked eye, no. And finally, if you have a larger reflecting telescope, larger aperture scope, then the angular size and the dimness of the objects you are able to see is different. So much smaller angular size, like the Ring Nebula shown on the upper left, it's quite small in angular size. So you need a larger scope to see it well. And also dimmer galaxies. A lot of the galaxies that Jim just showed us, he captured with his 8-inch Schmidt-Cassegrain. So fairly long focal length to capture galaxies that small, but also the aperture to gather the light because they're dimmer. M1 is another angular small size target, and it's moderate in brightness. And of course, planets and the moon, you can use a reflector on, but from the city, you're sort of limited to planetary nebulas, which tend to have a higher surface brightness, the moon and planets, unfortunately. So that's my recommendations for that. I'll switch over now to some photos. Oh yeah, no, there was one other thing actually, before people start dropping off too much. I wanted to just give everybody some additional information about the two organizations that worked together to make today possible. So the RASC, the Royal Astronomical Society of Canada, is the largest amateur astronomy organization in Canada, and certainly the Ottawa chapter is the largest group of amateur astronomers in the Ottawa area. And they have a large outreach program. They do monthly star parties at the Carp Library, and they have a lot of other activities that they do in the community. Working in parallel with RASC is a smaller group, but I might say more passionate group, called the OAOG, the Ottawa Valley Astronomy and Observers Group. And they focus more on getting out and hanging out together out under a night sky, observing together, as well as doing sidewalk astronomy. If you want to learn more about these groups or find out what they're doing, because we do meet regularly, we have meetings once a month, each of the two groups, you can follow them on Facebook, or you can check out their websites. All right. And finally, I have my own slide presentation of images.
And Jim, as you move into your own slides, just posing a question that's been put up in the Q&A box from Phil about the Malancam and how it can capture a lot of the deep sky objects from the city. Is that correct?
Yes. So there are a number of different brands of camera, and here I'll actually share this picture because it'll be good to talk around. Juggling a lot of screens here, but okay. So this is the setup that I used last Friday. I did an evening observing session with my daughter's scout troop, and this is from my backyard. So these are the two cameras that I use primarily. One of them is a Malancam. So that if you were here for the presentation I gave on electronically assisted astronomy, one of the main advantages to using a camera to collect the light that you're observing is that it can bring in light over a much broader spectrum. So a much wider range of wavelengths of light can be captured. Plus, it's the sensor is way more sensitive than the human eye. So those two things working together open up an opportunity for you to use a filter with the camera to cut out a lot of the light pollution. So when you use a filter, you're blocking a lot of the light that's coming into the scope. So visually, if you're using the filter, it has to be relatively bright objects. And typically they only work if it's something like an emission nebula, where you have very specific wavelengths of light that are being emitted, hydrogen alpha, oxygen 3, that sort of thing. So that does not really work well with galaxies that emit light over the whole spectrum at the same time. They're called broad spectrum emitters. So visually, using a filter does not help to get rid of light pollution observing a galaxy. With a camera, however, because it can see well up into the infrared, you can use filters to cut out most of the light pollution, but allow you to still see a substantial amount of light from the object, whether it's a nebula or a galaxy, because galaxies have a lot of emission in the infrared that you can take advantage of. So it's that expanded spectrum of the camera that allows you to observe in light polluted conditions in conjunction with a filter to be able to see things better. So this is, like I said, my setup. So I'll back up a picture. So the mount I use is a equatorial mount, and it's mounted on a concrete pier in my backyard. So for the people who missed the presentation earlier today on the different types of mounts, this mount is motorized and it rotates about 2 different axes. I'll sketch them in for you. So there's an axis here. That's the right ascension axis. So it can rotate about that. And then there's an axis here. That's the declination axis. And the right ascension axis, as part of the setup of the mount, is pointed directly at the North Celestial Pole. So very, very close to Polaris in the sky. So it's pointed right at the spot in the night sky that is the point where the Earth is rotating about. So that way, the mount only has to move about 1 axis to track with the rotation of the Earth. That's why they are typically better for long exposure photography. You have more accurate tracking of the Earth's rotation. So I've already kind of talked about the scopes that I have on there. The 2 cameras that I am using presently, and that has changed over the years. I am a bit of a technology hoarder. I have tried many different cameras through the years. This is what I'm using now and have been for about the last year. The red one on the left is made by that Chinese company, ZWO. And it's called an ASI 294 MC Pro. The Pro is because it's cooled. There's an electronic cooler in there that takes heat from the sensor away. And that's to reduce the noise of the sensor. Well, that's not a very good color, is it? Delete that. Choose a different color, can I? Yeah, I can. So it's a one-shot color camera, just like your DSLR. And the black camera that's currently on the 2.5-inch refractor is a Cam brand camera, and it is a Sky Raider DS432M tech. So the tech is for the thermal electric cooler, same sort of technology as the ZWO, but it's a slightly different design. custom designed by ROC. And in this case, the 432 refers to the model number of the sensor made by Sony Corporation. So those are the two cameras I use now. The monochrome camera, I use, the black camera is monochrome. I use it when I'm using very narrow filters, like a hydrogen alpha filter or the infrared pass filter, because it's much more sensitive than the red camera. But if I want a color image and I don't need to cut the light pollution so much, I use the red camera. So that's my basic setup. So I have a lot of objects in my photo shoot here that are copies of what the other people have. So I'm going to jump around a little bit just so I'm not repeating things that other people have shown. It looks like my image viewer has frozen. So I'm going to stop the share just for a sec. It happens sometimes. And then reshare it. Is it back? It's back. Okay. So it's going to put things into perspective. We've seen this picture of the Milky Way quite a few times. But one thing that wasn't really discussed was how our location in the Milky Way affects what we can see at a particular time of the year. So let me get my annotate tool here. So the arrow is pointing to roughly where we are located in our galaxy, or at least what scientists think for our location. And so in the summertime, it just so happens that our location, I'm going to put a little dot here where the sun is. In the summertime, it just so happens that at night, the Earth is facing this way into the center of our galaxy. And so the objects that we see in the summertime are primarily the objects that we see in this part of the galaxy. In the wintertime, the Earth is on the other side of the sun, and we are looking out this way in the wintertime at night. So we're looking at mostly this stuff. So in both of those cases, we're looking into our galaxy. So we're seeing a combination of open clusters, planetary nebulas, globular clusters, and a lot of emission nebulae. But in the spring and the fall, the Earth is looking up and down from the perspective, I guess, into the page and out of the page from the perspective of this picture. Out through a little bit of the arm that we're currently in, but mostly out into intergalactic space. So in the spring and the fall, that's when we tend to observe more galaxies, objects that are outside of our own galaxy. So a lot of the galaxy pictures that we've seen tonight by Simon, Lance, and Jim, they were taken, most of them during the springtime, because that's when we see most of the galaxies, but also some of them in the fall, like M31, the Andromeda Galaxy, we see that best in the fall. And then some of the objects we see in the summer and the winter. So I'm going to bounce around a little bit and give you kind of an example of some of my favorites from each of the seasons. So right now in the springtime, like I said, it's galaxy season, and there's many, many to choose from. So certainly one of the favorites, oh, let me clear that out. One of my favorites, and a lot of people's favorites, is M51. This image is taken with the monochrome Malencam camera, the 432, with an infrared pass filter. So we're only looking at infrared light from this galaxy. I like this galaxy because since it's closer to us, we're able to see a lot more intricate detail in the galaxy. We can see dust lanes, just like we see dust lanes in our own galaxy. We can see star-forming regions, so the brighter blobs that we see in the arms, so like here and here, those brighter regions, that's where there's active star forming, just like we see in our own galaxy. And we also see something that's that we don't see in our own galaxy, and that's interaction with a neighboring galaxy. So this is a small galaxy that was flying by M51, minding its own business. And because of gravity, it got sort of caught up. I think they think that it did a flyby, and that's where all this faint material out here is from. These are stars that have been thrown out of one of the two galaxies because of the interaction. But eventually this smaller galaxy is going to orbit around and eventually get sucked in by the larger spiral galaxy that has more mass. So that's one of my favorite spring galaxies. Another favorite is M81, which I believe Jim showed. It's another great example of a spiral galaxy, showing both the older, more reddish colored core of the galaxy. So a lot of the older stars are in this kind of spherical central part of the galaxy, and then we see more star forming out in the arms, and that's one of the properties of spiral galaxies. Most of the star forming is out in the arms. So that's another one of my favorites from the springtime. Just looking here quickly. So this galaxy here, this is with the monochrome camera again. This galaxy is very, very difficult to observe or image from Ottawa because it's very low in the sky. It's not very far above the horizon for us. And the reason it's interesting to me is because it's one of the galaxies that we can see that is a very close replica of our own galaxy. It has this central bar, so it's called a barred spiral. It has large spiral arms, but it also has these spurs that come off of it, just like scientists think our galaxy has. So it's interesting to look at it and to think that this is what some other civilization out in space in another galaxy is seeing when they look back at us. That's kind of neat. Okay, I'm gonna fast forward now into the summertime. One of my favorite summertime objects we've seen already tonight a couple of times, and that's the Lagoon Nebula, M8. And as Lance mentioned, you can see this object naked eye when you're in a dark sky. It's relatively bright, and it's relatively easy to observe. Most of the summer, it's well placed in the south, and I like it because it shows a lot of detail. If you're able to get a good evening, you can see a lot of the features, the different stages of new star formation. So we can see there's a lot of young stars here. So that's a new open cluster there. Relatively young stars, fairly hot. Similarly here, and it's these new young hot stars that are causing the nebula to light up in the first place. The UV light coming off of these young stars is energizing the hydrogen gas around it, causing it to glow red, and that's the light that we're seeing. The solar wind from those young stars is also pushing all that gas away, and we're actually able to see what's called a shock front all around the perimeter here, and there's also an inner one here. So this is, if you think of it's a cavity, you're looking into a cave It's three-dimensional. So these lines here are the edges of the gas cloud being pushed back by the solar wind of these young stars. And the last feature that's interesting to observe are these black blobs here that are floating around, all these black blobs. Over here, there's lots of them in this particular scene. So that's dust and gas that was cold enough and dense enough to not get pushed away by the solar wind of the new stars, the brothers and sisters stars, I guess, older brothers and sisters. Those areas were cold enough and dense enough to hold themselves together, and eventually they are going to collapse and become new stars. So those are sort of the starting blobs of gas and dust for new stars in this part of our galaxy. So that's why I really like observing that particular object. Other summertime favorites.
Jim, before you push on to the next image,
yeah.
A question from John about the previous image that had the barred spiral galaxy that looked like ours face on, and just wants a reminder of what was the name of that galaxy.
That's Messier number 83. I don't think it. I'm not sure it has a name. It might be the Southern Spiral or I'm not sure, the Southern Whirlpool, something like that, but it's Messier 83. It's quite low in the sky. I think it's around the constellation Virgo. I'm not positive on that. Another summertime favorite for me is the Eagle Nebula, as other people have shown, and again, it's just because there's so much fascinating detail to observe in this area of the sky, especially when you think about how the main feature, this supposed pillars of creation, that's a three-dimensional feature. Those are like fingers on a hand that are kind of resisting all of the solar wind coming from the cluster here, these new young stars. Those stars are trying to push all that gas and dust away, but those pillars are cold and dark, not letting light through, and dense enough that they're resisting being pushed away. And that's why we see the features that we see. So yeah, that's another one of my summertime favorites. What else? Now, some people say that I'm crazy to think this, but I call this the Dragon Nebula. I know it's a bit of a noisy image. It's because it wasn't a great night and I had to really crank up the gain, but I have another image. It's a little closer in. I'll show you in a sec, but I call this the Dragon Nebula. It's known as the Gamma Cygni Nebula or the Butterfly Nebula, and it's in the middle of Cygnus the Swan. The bright star here is Gamma Cygni. It's the bright star in the center of the cross that makes up the Cygnus constellation. And this is an open cluster here. So I consider those to be the eyes of the dragon. This is its mouth. It's got some teeth here. Nostril. Anyway, that's what I see. Maybe I stay up too late and I'm getting a little bit wired, but anyway, that's what I see in that constellation, in that particular object. Well, it's even more fascinating if you look at it with a hydrogen alpha filter. So the stars are really subdued, allowing you to see more of the detail in the nebulosity behind. So this is more hydrogen gas excited by young stars. But we can see here the fine details of the dust that's the cold dust that's intermingling with the excited hydrogen gas. And it's just, to me, it's quite fascinating. You can just keep diving in deeper and deeper and finding more and more layers of complexity in the scene. So that's one of my other favorite summertime objects for sure. Moving on into the fall now. We saw already this object, the Wizard. This is again with hydrogen alpha using my monochrome 432. So the reason this is called the Wizard is because for some people it looks like a magician with a long cloak. These are the sleeves of his cloak here. If I have that right. I'm trying to sketch it in here. So this is a hand. This is a hand. This is his flowing robe. And on his head, he has sort of a, I don't know, a wizard hat, sort of. Anyway. So that's what somebody one day said they thought they saw. So they thus named this object the Wizard. But it is another star forming region. So again, you can see these here are shock fronts. So this is the edge of the cloud of hydrogen gas being pushed back by the new stars that were formed in the area. And we see lots of globs of darker material where it's much colder and denser. So yeah, that's a fall favorite for me. Another fall favorite is the Pac-Man Nebula. This one is maybe a little bit easier to see. It looks kind of in the shape of the Pac-Man. And it is yet another star-forming region. So this is the open cluster here that's pushing all this material away. Here's the shock front in the cloud. And it just happens that this thing here is in the foreground from our perspective. So the cluster is actually partly behind that that sort of pillar of dark material. And it looks sort of wispy and windblown because it actually is being blown away. It's being blown by the solar wind of the young stars that have already formed in the cluster. So like, if you think about it that way, you kind of see this in 3 dimensions. Another fall object that I enjoy observing but is a little bit challenging to observe is this object. This is a planetary nebula called the Helix Nebula. It's much more impressive in color, but I have not managed to gather a decent color image of this yet. Just like Messier 83, it's very low in the sky from Ottawa, so it's difficult to see through all of the light pollution and the dust and the haze that's close to the ground. So this is the best I've been able to get so far of this object. It's a planetary nebula, but it is one of the closest planetary nebulas to us. So it's quite large in the sky, and that makes it relatively dim, which is another reason why it's harder to capture. Moving on to the last season. So winter, now we're looking back into the arm outside of us, the arm outside of us in our galaxy. And of course, one of the favorites to look at is M42. I'm going to make that fit the screen. It's just a glorious nebula. It's very bright. You can see it easily in the city with a telescope or binoculars, even through light pollution. It's that bright. But when you put a camera on it with a light pollution filter, the detail that you can pull out of it is really mesmerizing. And just a note, we didn't really talk too much about it today, but you can see several different colors in this particular image. You see red, which is very common. The red is hydrogen gas. Sometimes you'll see green. The green is specifically oxygen that's excited and lost its electrons, just like hydrogen. We see blue. There's some blue up here, a little bit of blue on the fringes here. And around here, it's more blue, a little bit of green mixed in. Blue is reflection of starlight off of dust. So if you have young blue stars that have formed in this area, there's a nice bright one down here, and there's many in here. That's why it's overexposed in the center. The blue light from those stars is reflecting off of the dust and making the dust appear blue. And the final thing is brown, which you can see kind of around the perimeter here. The brown is dust. It's dirt, essentially. It appears brown because it's blocking the light behind. Just to kind of give you a primer on the colors that you see. So yeah, definitely M42, one of my favorites. Another one of my favorites, it's actually kind of a region. If you go up in the sky in the Orion Nebula a little bit, you get to this area. This is the right along the belt of Orion. So these two stars are the first two stars in the belt. And there's two lovely objects in this part of Orion. There's the Horsehead Nebula, which literally looks like a horse head. And then the Flame Nebula, which indeed looks like a flame. And these are both areas of new star formation as well. In the case of the Flame Nebula, the star formation is behind the nebula. So we're seeing dust between us and where the stars are being formed. But eventually, those new stars are going to push all of that gas and dust out of the way, and we would be able to see into the interior, into the cluster. It'll be millions of years before that happens, but eventually that's going to happen. The Horsehead is a big mote of cold gas and dust that's blocking the light from the emission nebula that's behind it. So the red that we see around it is excited by the stars that are in the background. And then in front of all that is this kind of head-shaped blob of cold, dark material. So another lovely wintertime object to observe. What else do we have here? I think that is about it. We're past 11 o'clock, so I am happy to finish it there, unless
Jim, I'll pose
want to go on.
One final question that's been put on the question and answer, and my apologies to the person who asked it, because he's actually left the webinar since asking it. So I left a simple one for you at the end, and I'm not sure whether you'll be able to answer it with your physics and engineering hat, or may have to shift hats over a bit to your philosopher hat.
Uh-oh.
and I'll invite any of the other remaining speakers. We have 5 other speakers still online. Simple question: do we know yet if the universe has a order beyond which something else exists?
Ooh. I don't think we know that. There's speculation that it's an infinite. There's speculation that it's finite. I don't think we have enough evidence to say that. They're hoping that the James Webb Space Telescope will extend the horizon of our observation closer to the Big Bang. Maybe we'll learn more about the nature of the universe beyond what we can observe now, but I don't think it's determined at this point.
But I see that Simon has unmuted himself, so maybe he would like to chime in.
Counterpoint? As with so many of these things, there are so many schools of thought. One of the schools of thought, of course, is the idea of multiple universes. One of the variations on the multiple universe theme is that we are one bubble. Our universe is one bubble amongst many. In other words, that if you were to go to the quote unquote edge of our universe, you would simply come up against a wall between us and the next universe over as a bunch of bubbles. This is all philosophical, as you said, Chris. We have absolutely no evidence whatsoever, as Jim says, for the universe being finite or infinite. In the end, it really comes down to Fred Hoyle and the Big Bang. When Fred Hoyle first heard of the Big Bang, he laughed, and he called it the Big Bang in a derogatory fashion, because for him, the universe was constant. And the universe had always been there, it would always be there, and it was therefore infinite. The Big Bang implied that it actually started somewhere, which means that it must actually extend out to some kind of a boundary. We don't know. It makes for great debate, great discussion, especially over a beer, as I see Jim is already there.
Yeah.
But otherwise, it's philosophy.